Study variables and measurements. 1. Understanding variables. Definitions and types. Variable, a characteristic of a person, object, or phenomenon that can take on different values. Common types of variables. Numerical, takes on numerical values, e.g., age, weight. Income. Discrete, whole numbers, e.g., number of drinks, age and completed years. Continuous, can take any value within a range, e.g., weight. Height. Categorical, takes on categories or labels, e.g., color. Disease. Outcome. Dichotomous, to categories, e.g., yes, no. Death. Survival. Nominal, categories with no inherent order, e.g., ethnicity. Occupation. Ordinal, categories with a ranked order, e.g., severity of disease. Mild, moderate, severe. Dependent variable, the outcome or effect being measured. Changes as a result of the independent variable. Synonyms. Effect, outcome, consequence, result. Condition. Independent variable, the variable that is manipulated, treated, or assumed to cause, influence the dependent variable. Synonyms. Predictor, cause, input, risk factor. Can be hierarchical, immediate, proximal, underlying, or distal. Background factors. Note: not all studies, especially descriptive ones, require clear-cut dependent and independent variables. Confounding, intervening variables, variables that might influence the relationship between independent and dependent variables and need to be considered. Background, socio-demographic variables, commonly relevant variables in group population studies, e.g., sex, age, ethnic origin, education, marital status, social status. 2. Selecting and operationalizing variables. Identification. The starting point for identifying study variables are the study objectives. Break down objectives into component themes or constructs. Factor identification. Identify factors of interest by asking, what do we want to learn in this theme? What factors are needed to get information on what we want to learn? Are any important factors missing? Rephrasing. Converting conceptual factors into measurable variables, e.g., long waiting time becomes waiting time. Absence of drugs becomes drug availability. Operationalizing composite variables. For variables that cannot be measured by a single item, e.g., client satisfaction, quality of care, wealth, level of knowledge, nutritional status. A battery of questions or multiple indicators are used. Example: level of knowledge can be operationalized by a series of questions with a scoring system, e.g., 0 to 3 correct answers equals poor, 4 to 6 equals reasonable, 7 to 10 equals good. Example: nutritional status of under 5-year-olds can be operationalized using indicators like weight for age, weight for height, height for age, or upper arm circumference. 3. Measurement techniques and data collection. Ensure timely editing, coding, correction of forms. Consider multiple measurements where needed. Validate against a gold standard, blind to exposure status, and institute quality control during all stages. The measurement spectrum. After deciding the exposure, outcome of interest, measurement includes instructions for applying the method, the measurement method itself, delineation of steps for preparing data for analysis, and quality control procedures. Key considerations before measurement. Pretest tools. Refine, automate instruments, train and evaluate staff, e.g., height, weight, blood pressure, or observing and recording specific behaviors, events using standardized protocols. Common data collection methods for quantitative variables. Direct measurement. Observation. Using instruments to directly measure physical attributes, crucial aspects. Standardization. Instrument calibration. Thorough staff training. Control of environmental factors. Surveys. Questionnaires. Collecting data on attitudes, beliefs, knowledge, experiences, etc. Typically using closed-ended questions, e.g., multiple choice. Likert scales, but sometimes open-ended questions for quantitative coding. Crucial aspects: clear and unambiguous wording, exhaustive and mutually exclusive response options, pilot testing. Existing data sources, secondary data, utilizing pre-collected data from official statistics, medical records, organizational records, or prior research. Crucial aspects: access, relevance to research question, critical evaluation of original data quality and potential biases, tests and assessments, standardized instruments to measure specific constructs like knowledge, achievement, or psychological states. 4. Ensuring measurement quality, reliability and validity. Reliability, consistency, the extent to which a measure produces consistent results under the same conditions. Types: test, retest. Reliability, consistent scores over time. Internal consistency. Reliability, items within a scale measure the same construct, e.g., using Cronbach's alpha. Inter-rater reliability, agreement between different observers, raters. Parallel forms. Reliability, consistency between equivalent versions of a test. Validity, accuracy, the extent to which a measure truly measures what it is intended to measure. Types: face validity, the measure appears to be relevant and appropriate. Content validity, the measure covers all relevant aspects of the construct, encompassing convergent correlates with related measures and discriminant does not correlate with unrelated measures. Validity, criterion validity, how well the measure correlates with an external criterion, leading to more robust and trustworthy research findings. Concurrent validity, correlates with a criterion measured at the same time. Predictive validity, predicts a future outcome. Construct validity, the overall extent to which the measure accurately reflects the underlying theoretical construct. By understanding and meticulously applying these principles, researchers can ensure that their study variables are well defined, appropriately operationalized, and measured with the highest possible quality.